In my ongoing series at looking at social media experts, we're going to take a look at, an objective look, at what people are putting out there on social media regarding exercise. And they're all telling us how everybody should do an exercise, what is the best exercise. They don't discriminate between whether someone's 9 or 19 or 90 or their goal or anything else. If they're willing to put it out there, it's for everybody. They're perfectly happy to getting likes on social media, maybe even a thumbs down by people on social media. I hope they're also tolerant of objective critique of what many of them are saying is science. So let's take a look, and specifically this time, we're going to look at something, pulleys, equipment. Equipment is incredibly important to me. Equipment has just been one of my favorite things to do, to analyze, to work with. I've worked with 2, 3, 4, 5 major equipment companies across the past 30 years as a consultant, as someone helping with design of specific lines. And there's always compromises to be made. Certainly, one of the toughest parts of my program is the equipment analysis portion. Something that is online, something that has always been challenging to people, and people do really well. Even the relatively large number of examples and analyses that we do in practical labs still typically aren't enough experience and information and not a vast enough understanding to analyze every piece of equipment out there. Now, arguably, pulleys are among the easiest, but can actually get far more complicated than you think. The number of things I've heard out there over the past 30 years that people have said incorrectly about pulleys is absolutely amazing. So let's take a look at a few specific examples and see what we see. This person is incredibly popular out there, and this is part of a regular series that he offers called, this is part 2 of It's Physics, Bitch. And he enjoys saying it even more than I kind of do. It's kind of funny. But this part 2 is specifically entitled, Are Cable Pulley Machines Making You Weak? Uh-oh. Are cable pulley machines making you weak? I mean, even if you don't use them, just walking by them and you get weak, you know? But do you ever just watch that? Hear people say these titles and read these titles and go, what? Well, let's take a look. Some direct quotes from this video. We've proven it. Why having an understanding of physics can have a huge impact on not just understanding your workouts, but the results you get from them. It's interesting when someone says they've proven something, as opposed to the idea that there's considerable evidence that. So I would like to see how this person has proven a difference in results from a level of understanding, not from applying it. Sometimes the way you apply it's more important than just the understanding. Here's the bottom line for us. If all you're using is pulleys, you're not as strong as you think you are. I guess that has a lot to do with how you're measuring strength. In our strength section, we talk about what is strength, and that's a much more in-depth and expansive topic than you might think. But if you're playing by the numbers game, as most people, without a doubt, numbers are deceiving. Pulleys are things that can deceive you relative to the number that's on the weight versus the number that you actually have challenging you as the magnitude portion of the torque equation, the torque of resistance. If all of this is already complicated, please realize my social media stuff is no more education than theirs is. This is just helping to hopefully enlighten you to the fact that there are people out there that are very well spoken and very, very, very popular. They are very often, however, articulate incompetents. They sound smart, they overwhelm with their words, and sometimes they're just flat, mathematically and physically wrong. It all depends on the number of pulleys you're working with. Take note, it all depends on the number of pulleys that you're working with. A redirection of the force that makes it a little bit easier. He's saying that's what pulleys do. Just count the pulleys as we go. The more pulleys, the easier it gets. The more pulleys, the easier it gets. Now, I don't know how much easier each pulley is supposed to make it. Does each pulley make it 10% lighter? Does each pulley make it half and then half again and then half again? Is it 10% of the original number each time? Is it 10% of the leftover number each time? It's just randomly easier? Seems like equipment is an engineering entity. Seems like it has the complete ability to be calculated in terms of what it offers. Easier is a pretty relative term. There's probably a number associated with that. So it's time to count the pulleys. Are you ready? By the way, we're going to refer back to this. You've seen these functional trainers. This one has a pulley actually above the cable and below the cable so that as it spins, maybe each one would come in contact when appropriate. Keep that in mind. He's going to take a look at a machine, and we're going to count through the pulleys in the machine, and we're just going to see what we can identify, and then we'll go back and take a look and see what reality says about this. Maybe he's spot on. We'll see. 8 million followers couldn't be wrong. So here's pulley number 1. This is kind of on a multi-station machine, more of a home version, and it's like the pull-down portion of that machine. So there's a ball that you commonly see on these cable machines that keeps the cable from being pulled through when you're doing something else on the other end, okay? So there was 1, cable goes down to 2, cable goes back to 3, cable goes back forward to 4, goes back again through the machine to 5, down to 6. There appears to be a 7th. Something weird here. Come back up to the top and there's an 8th, and then finally there's a weight stack over here. See that? It's behind the word there. So he comes along in the more of the audio portion of the video and he says, you have to have an understanding of where you have to, oh, I messed up probably. You have an understanding of where you're naturally at. And he's talking about strength. You're going to go crazy wondering how strong you're actually getting. Now what he's referring to is when you walk over and use a traditional pull-down machine, then in class we learn as a one-to-one relationship of resistance to movement in terms of relative distance moved. And again, if you're going, wow, I don't follow you, that's because this is not a class. There's hours and hours and hours of this within the course library on exerciseprofessional.com. And it is understanding that would help you follow along here. In fact, you might not have needed me to do this, and you would have maybe been able to solve some of this yourself and have an objective critique of your own. Very empowering, actually. No longer falling prey to the traps of following the articulate incompetence. But sometimes pulley systems that stray from the old traditional pull-down machine can alter the magnitude of force that weight offers by the time it's translated through the pulley system. And yes, sometimes you'll find that 100 pounds is actually 50 when you move it, due to the mechanical advantage created by a very specific arrangement of pulleys and anchored components, not just the number of pulleys as we're going to see. I believe that's why he's saying, well, you were using 100 on that machine, you come over here and you put 100 on this machine and it's only 50, you don't know if you're getting stronger. I don't think that's ever going to be the case. I think you'd probably go, wow, this is only half as heavy. Maybe I'll do something to change that. Maybe I'll adjust things. But let's go on here. Count your pulleys. The more you see, the less work you're actually probably doing. Well, you either are or you aren't. This again is going to be math. So how much challenge is there? Is it probably more or probably less? Is there a probably in math? I guess there's probability, but there's not a probably. So let's take a look at this thing that's very similar to the pull down I was telling you about. It's simply a single pulley, and when it's 30 pounds on this end, it's 30 pounds on this end. If it moves 4 inches here, it moves 4 inches there. The speed is the same of the handle and the weight. Those are all important factors because there's more than just weight involved in resistance. Here's a second pulley. So according to our source on social media, the social media expert, this should alter the load, when in fact all it does is redirect. That's all pulleys do. That's all a pulley can do, is redirect force. It doesn't change in and of itself. No matter how many you add in there, it doesn't automatically start changing the amount of force. It changes the direction. In this case, we've redirected twice, 30 still being 30. By all factors, all ways we can measure it, and all the influences of that. Now, in the end, the resistance is not 30. Because resistance is torque, and we need to know that. Even if this is 30 when your arm's out straight, and 30 when you're back here, which it is, it's not the same resistance at the start and at the finish. Even though this hasn't changed. Because of torque. There is zero moment arm here if in fact the line of force is resistance is falling through your arm. So at the elbow, and at the shoulder, now certainly in the trunk and the scapula there are different things going on. But that 30 pounds is not a consistent resistance here, even though it's still 30, because the torque is different. I come back here, it's still 30 from the handle, right? It's still 30 everywhere throughout the range. But the moment arms change, so the resistance has changed. Now, if we're not factoring that in as resistance, we're just lost already, because resistance is torque, period. But we'll forego that for a minute and go back to the idea of, is it still 30? Here is something that changes things. We're going to call this a 2-to-1 relationship. Sometimes you'll hear it represented as a 1-to-1 half. The point is this. The configuration of the pulley system is different. Whereas before, in our little picture, the cable was in your hand and the other end, while wrapping around a couple pulleys, ended up directly attached to a weight stack. Here we see a very different configuration where the cable never touches the weight stack. It's anchored on a machine, goes around, and then goes to you or to a piece of an input arm or input pad or something that you might be pushing against. This changes things. This truly alters things because there are two cables holding up that weight, one of which is you, one of which is the machine. So what have we got? Well, boys and girls, this reduces the load. How much? By exactly 50%. It also alters the inertial effects. So there's another factor that hasn't been figured in here. Ironically, the inertial effects can actually make it so it remains heavier. When you've got the 1-to-1 relationship with a single pulley, you can yank on that thing, and because it's 1-to-1, the faster you go, the faster it's going. Sometimes you've seen the slack in the cable. That's when the resistance is actually decreasing because it's still going up maybe when you're trying to go back down. So I don't know if that's been calculated into his effects of execution on how you use a pulley system and the resistance, but it's an objective physics-based factor. So what happened here? Well, this actually is moving only half the speed because it went half the distance in the same period of time. So the inertial effects, acceleration, deceleration, are going to be less. If all this is a foreign language, we need some real education, people, and it's not on social media, including my little post here. 4-to-1, what does that mean? Well, in this previous example, you saw a single pulley. Now in real life, you will often see, depending on the device, 2 pulleys directly attached to the weight stack. Now there are literally 4 cables holding the weight. If it's 60 pounds, each one of those that's sharing some load equally, so it's 15 pounds each. If you're pulling on one of those, you've got 15 pounds. This is closer to what he's talking about. And it's not a problem. You will probably never be confused by grabbing something that's 1-to-1 and going, wow, that's 60 and that's heavy. And then putting 60 on this and pulling on it and go, am I still getting big? What do you think? When you go pick up a heavier dumbbell, and then if you were blind and pick up a lighter dumbbell, would you just keep using the lighter dumbbell thinking it's the same? Pull on the other one, moves a little bit further. Each one still had 15 pounds. Now we're back to one pulley. Given that we're back to one pulley, it should be no reduction in load, right? it shouldn't be making it easier. I don't think he said one pulley made things easier, did he? I don't remember actually, but here's the one pulley, and we have a very different situation, but you're going, oh wait, Tom, it's like the first one because the cable goes to the weight stack. It's very different. Oh, it's like the second one because it was anchored to the machine. This one's anchored. Well, it's got some traits of both, doesn't it? Here's the thing that's interesting. While being anchored on one end and attached to the weight on the other end, this is where you would come into the picture. This pulley itself will actually be moving in space, just like these pulleys were moving in space. You see, it's not how many pulleys. Look at this, 1, 2, 3, 4, 5, 6, 7. What does 7 have to do with the fact that that is 25% of the load? Nothing. It's these guys, the ones that actually were not just sitting and spinning, but were actually moving up and down. And in this case, the one moving up and down is not attached to a weight stack, but it's attached to you, to an input arm, to some piece of a machine. You know what this thing does? It doubles the load. It doubles the load. It's used in machines all the time. Machines where you need more load and they don't necessarily want to give you a 1,000-pound weight stack, or in machines where you end up with mechanical advantage because of where your grabbing handles are pushing on a foot plate and the load is attached much closer to the axis of that input arm. Therefore, you have mechanical advantage, so very many times they will double or triple the resistance via a pulley system in order to bring it back to the same thing. 300 is pretty close to 300 on your feet, pretty close. Because of the pulley system, because of actual increase, this pulley system, well, there's a pulley here and a pulley here, this pulley system doubles the load. This pulley system doubles the load. This pulley system doubles the load, and on the other end, it cuts the load in half so that you can have 50% of that doubled load on each side in this lateral raise machine. So if you count the number of pulleys, does it tell you anything? No. What the pulleys are specifically doing in the pulley system are the key. They are the key. And if again you're going, wow, this is too fast, well, I don't understand. This is social media. This is not education. This is just helping you to see that there are objective realities behind these things. And I'm not sure that social media is the place to truly become educated in them. This is the machine he was actually trying to analyze, or close to it. It's a similar brand. It's actually the same brand. It's a different model. But the idea was the same, is why I chose this one. I couldn't find a picture of the exact one on the internet. But the point is that there's a pull down at the top where he started counting. Then there were multiple pulleys that we worked our way through here, and we're going to do that again. The thing I want you to see is whether you're doing this exercise or whether you're doing this exercise is going to be a very, very, very different relationship of pulleys and anchor points. In fact, every one of these multi-station machines, you often find them in hotels. They're common in homes because you end up with one weight stack servicing, in this case, 1, 2, 3, 4 devices. One weight stack. That means the cables associated with each one of these exercises have to somehow find their way to this weight stack, while somewhere co-joining and intertwining with the other cables from the other devices. And the goal is that each one of them doesn't interfere with the function of the other. This is why you can't use this exercise and this exercise at the same time. It is important for each one of these others to be static when you're using that one, so that their little individual pulleys aren't influencing this thing. That's a lot, I know, but these are by far the hardest pieces of equipment to analyze. It would sure be nice if we could just count pulleys, but it's a little tougher than that. So here he is, he's got his handle, he's pulling on the cable. Up here is our first pulley, which will never do anything more than turn the redirect because it's got an axis and it will sit and spin, and that's it. It comes down to another pulley that while he's pulling on this thing, pull down portion, this pulley will remain static. It will spin, but it will not move linearly in space. It redirects back to this, redirects, again doesn't move in space, never will, it's welded to the frame. This one will also move in space at some point, but not during this exercise. And if it doesn't move linearly in space, it's just a redirect. It is not influential in the amount of force generated by pulling on the other end of the cable, not in this specific exercise. We take back through there, through a hole, through a static pulley again that's also on this welded support, comes down around a pulley and goes back up. This cable has nothing to do with what's going on down here, unlike that lateral raise machine where you might go, oh, I've seen that before. I've seen two pulleys attached to each other, and I know one's going to cut it in half. One's going to double it, and the other's going to... Wrong. It's not that simple. You can't even take things that look similar. You have to have watched this thing move. You have to know what the features provide. You have to follow it all the way through. It's not as simple as people make. And this by far is the toughest. This will not move. This will simply be another redirect, up to the top to another redirect, and down to the weight stack. This pull down is 1-to-1. There's about, 7 or 8 pulleys in there. And all it did was redirect, and none of them moved linearly. The pull on the handle, 12 inches, the weight stack goes up 12 inches. It's a 1-to-1 relationship. Put 1,000 more pulleys in there in a similar redirecting fashion. It'll still be a 1-to-1 relationship, except the 14 miles of cable will eventually stretch, okay? So let's go back and look at this guy from another point of view. Same number of pulleys, but are they in play the same way? So we're going to pretend that he's pushing forward. So this handle is going to go, this is going to be static. This is not going to be pulled down this time. This ball is going to be smushed against here, because when this pivots, this goes down to the handle, and he pushes forward, these pulleys are going to come forward. These were attached to that handle. See these two guys right here? So when this handle moves, these pulleys are going to move. So what? Well, we're going around a moving pulley, linearly moving, wrapping around a static, only pivoting pulley, back to the same thing and back again. Do you see that? So what have we got? 1, 2, 3. Yes, it's the same cable, but it is this kind of configuration that changes things. Whereas before you saw 4 cables attached to the load and you were pulling on one of them, that cut the weight 20 to 25% at the handle. This time, those pulleys are not on the weight. The weight is on the other end where you were in the previous example. These pulleys are making it harder. And the fact that there's 3 of them pulling against your handle, those pulleys triple the load. Now you won't know that because, as you remember, your handle is way the heck down here. You're almost, oh, miraculous, 3 times further, like a wheelbarrow. What does that mean? Well, to you, it's 1-to-1 again. That's the purpose of tripling it, because of the rest of the leverage of the machine. You can't just count pulleys, friends. So you get back here, go through the whole thing. All the rest of those are relatively static. Here's the machine that was, here's the machine that was behind him when he was standing there, and I said, remember, we're going to talk about that later. There were 2 pulleys on each side, each arm, up by his head. Do we count both of those? Well, there's a cable's only wrapped around one at a time based upon which way that swivel is facing. Do we count the pulley that's inside of here? I doubt that he knows it's there. There's a pulley in here. There's another pulley in here. This goes up to another pulley and down to this thing and up again and around again. 1, 2, 3, 4, 5, 6, 7, 8, 9, about 9 or 10 pulleys on this one side. What do those do? Well, if you look inside, there's only 2 of them that matter on that side. Now we can't see that one very well. This one you can kind of see that there's 2 pulleys. There's the same thing over there. My point is those 2 pulleys, 4 cables, this time the double pulley attached to the weight stack, not to the thing you're pushing on, makes this 25% of the load on each side. I still don't see a problem. I see lots of benefits. I see inertial changes. You want to move fast, the weight doesn't just fly in the air. You want to move far, if that's got 3 feet of guide rod, you got 12 feet of travel with the handle. This thing provides all kinds of things. Counting the pulleys doesn't tell you. And there's more. It all depends, he said before, on the number of pulleys you're working with. Have we found that to be true? It's objectively wrong. A redirect of the force that makes it a little bit easier. Redirection doesn't make it easier. Redirection redirects. The more pulleys, the easier it gets. Not true. But even in his machine, where it's 4-to-1, you know what I would do rather than standing there wondering if I'm going to get it strong, wondering if my pulley machine is going to make me weak, I would pull the pin and put it down to 120. From 40 to 120. Oh, it'd be 160, right? Is that 40? Yeah, so down here below to 160. If it's 25%, now we brought it back up by going to 160. And now you've got your load that you had in a 1-to-1 if you were using 40 pounds over there. You would be moving 40 pounds here if you put the pin down there. Look how easy. Isn't that great? That's what we learned from this thing. The bottom line is, folks, if you did 8 reps to failure on the regular pull-down machine that was simply a redirect, and you came over here and put it on 40 again like you did over there, you'd figure out real fast it's going to be about 100 reps to failure. You might just use logic, forget the numbers, and say, wow, this weight I can kind of do 8 reps to failure again. It's likely to be down here around the 120, 130, 140, 160, more likely, if we're using math. So, it's just not that difficult. It really isn't. Let's count pulleys on this machine. It's interesting, really interesting. The Pilates Reformer is super interesting. If you've seen them before, and many of you have, it's a pulley-oriented device, and yes, there's an elastomer, a set of elastomers on the other end. That is your primary source of resistance. Elastomers, of course, are an increasing magnitude. That does not always mean increasing resistance, because of what? You guessed it, moment arm. Now, we've got a single pulley here on each side. Now, we're not going to worry about the relationship between these pulleys, and the reason why is because they are not united through another pulley system. This is independent of this, with the exception that your resistance is being shared by both sides, not unlike a barbell would be in both hands. So here's a single pulley. This is not a pulley, it's an attachment point, so you can adjust the length from here to the handle. What's interesting about this is this single pulley creates one of the most interesting mechanical advantages I never would have perceived this until I experienced it, and then I had to sit down and say, what's the math behind this? This is cool. This was an experiment. Someone lying beside this, traveling through this travel of the handle, this distance, let's say, and it produces a specific excursion relative distance moved of the carriage. Now, if I actually put the person on here like would be using it, by the way, that was a 1-to-1 relationship. If I put the person on here and they travel through the same exact excursion of their hands, that carriage only moves half as far. Because this total travel of the hand, part of it was taken up by the carriage moving this way and the handle moving that way. It was kind of splitting the difference. It's actually half the resistance, and it's measurable. It's measurable, like all physics is. So, one thing to realize is the fact that pulleys in certain configurations might alter the load. Could be more, could be less, could be inertia, has to do with execution. We also need to realize that's not unique in our world. 45-degree leg press is only after 71% of the actual resistance loaded on there if you also measure, of course, the foot plate and the carriage itself. 71%. I don't hear him screaming about the 71% and how you're not getting as strong. Don't you, if you're going to do a 1-rep max, don't you just put on the weight on there until you can do a 1-rep max? Every machine we've got, the purpose of it very many times is to alter the resistance throughout the range of motion, be it a linkage system, a cam, combination of linkage and cam, combinations of pulley systems, linkage and cam, and sometimes linear movement that's not vertical. All of these things together, and especially if they're together, make it so you have absolutely no idea how much resistance you're moving. That's why it's more important to pay attention to the amount of effort or challenge for the number of reps you want to perform. The numbers are always a lie. Always. So the bottom line here is, it's physics, bitch.